welcome back. Let's do question 422. We're given that the graphs of f of x and g of x are sketched below. We have f of x, the quadratic function, g of x, which is exponential. E and h are the x-intercepts of f. C is the y-intercept of f and lies on the asymptote g. And then we managed to find that the coordinates of C are what? 0, -5 in the previous question, in this question. The two graphs intersected D. So this is the point of intersection. And the turning point, D is also the turning point of F. The instruction says, determine the coordinates of D. So we are determining the coordinates of what? Of the turning point. Right? How do we find the coordinates of the turning point? We can use the axis of symmetry of what? Of a quadratic function. Remember that x is equal to -b divided by 2a. So from the equation, our b is -4 and our a is 1. That means x is equal to negative minus -4 divided by 2 times 1. We get that x is equal to 2. Then how do we get the y coordinate of point D? We have to substitute our x coordinate into the equation, into this equation. Y is equal to 2 squared minus 4 times 2 minus 5. 4 minus 8 is -4. -4 minus 5 is -9. So it means the coordinates of D are 2, -9. So D is 2, -9. Okay. The other thing we can do, we can find the derivative of f of x is equal to x squared minus 4x minus 5. Remember, at the turning point, the derivative is equal to 0. The gradient at the turning point is equal to 0. The derivative is the gradient. So f prime x is equal to 2x minus 4. So at the turning point, this is equal to 0. And then we solve for x. 2x minus 4 is equal to 0. 2x is equal to 4. And x is equal to 2. Then we're getting a 2 just like here. And then we substitute the 2 into the function like this. And then we get our coordinates for D, which is 2 and -9.